And the final aspect we're going to look at here is just see how our graph matches up to the actual flight of the ball. You can see that when the ball is released from my hand, let's go to the beginning. Let's walk it through here. Let's walk it through, walk it through, walk it through. Right about here. The ball begins below the rim, as is indicated in the video. Now we look at our graph. Move it over a little more to the left. Alright, and let's move this over. Come on, come on. Shrink it. Okay. The ball begins at a height of roughly 2 meters, right? Now let's play it. When the ball passes through the rim, you can see that the rim is higher than where the ball was released. So when the ball finishes, the ball begins at roughly 2 meters. When the ball enters the hoop, it does so at between 2.5 and 3 meters, roughly 2.75 meters above the ground. So our video, the flight of the ball, as is shown in the video, is corresponds to the shape of our parabola in our graph. Now there are a few discrepancies. If you look at our data table, you can see that while the average slope, let me look at our graph, our average slope in the x direction was negative 3.152 meters per second. And we know that there should be little to no acceleration in the x direction. However, these points, look at 2.2 seconds, the velocity is negative 3.693. Then at 2.9 seconds, it's negative 2.619. Those discrepancies come from inaccuracies in the clicks. You can see, you kind of see in this path, the video is not of superb quality, but it's you can see that this is not a perfect parabola. Well, the shape of the path of the ball is a perfect parabola. I did not quite trace a perfect parabola here. And there also is a little bit of air resistance acting on the ball as well. So when the ball is released from my hand, there's gravity acting on it downwards in the y direction, entirely in the y direction. Gravity pulling the ball down, and there's also some air resistance acting on the ball, a force of air resistance acting on the ball as well. So that wraps up our projectile motion analysis.